to see the next protocol, that is RDT 2.0. In RDT 1.0 we said like it would not be having bit errors or no loss. In that sense, what happened in the RDT 1.0, the transport layer is just getting the data and it converts it, it creates the packet and deliver it to the underlying layer at the sender side. At the receiver side, the transport layer receives data and extracts the data from the packet and delivers to the application layer. This is what happened at the RDT 1.0. In RDT 2.0, we are assuming that there are some bit errors in the channel. In that case, what we can do is, underlying channel may flip bits in packets. Checksum is used to detect the bit errors. Okay, if errors are there, then the receiver should take some, sender and the receiver should take some initiative to detect and correct the error. So for that we need some mechanism. The question is how to recover from errors. Okay, when the receiver finds that the data whichever it has received contains error, what it should do? So it should intimate the sender so that the sender can retransmit the data. This is what happens. Okay, acknowledgement. So if it gets the data correctly without any error, it provides the acknowledgement, that is ACKS, which means that received correctly. Negative acknowledgement, what does it mean? Negative acknowledgement is nothing but if the receiver finds that the data is not correct, then it gives the negative acknowledgement. Sender retransmit packet on receipt of negative acknowledgement. Yes. So new mechanism in RDT 2.0 is two things. One is error detection and the other one is receiver feedback, that is acknowledgement and the negative acknowledgement. Yes. We'll see now FSM. This is the FSM of RDT 2.0. As usual, at the sender side, the sending process waits for the call from the above. So if it calls, if the application layer calls from the above by initiating the event RDT of send of data, then what is the action taken by the transport layer at the sender side? If you see, it again as usual it creates the packet. See, send packet is equal to make of packet. Send packet is equal to make of packet of data, checksum. So after the sending process initiated by the application layer, the transport layer will create the packet. And one more parameter added extra here is, as we are seeing here, checksum. Make packet of data, checksum. What is the use of this checksum? It is nothing but it helps to detect the error. See, checksum is added as a one more parameter in creating the packet. It helps to detect the error. So the sender will find the checksum value of the data and it will attach along with the data. So when it goes to the receiver calculates the checksum value on the data, and if the checksum value calculated by the sender and the receiver are same, then the receiver will come to the conclusion that there is no error in the data sent. If at all it is not equal, then it will find out that there is some error during data transmission, then it will send the negative acknowledgement. Okay, so for that sake we are attaching one more parameter called checksum. Okay, so then once the packet is sent, it will go to the next state. See, as I said, one event will be initiated. For that some action is taken. The action taken is sends the packet, that is creating the packet with the two parameters, and after taking this action, it goes from one state to the next state. First it was in the state called wait for the call from the above, then it moves to the next state, that is wait for the acknowledgement or the negative acknowledgement state. Then why it is waiting here? Since till it gets its acknowledgement or the negative acknowledgement from the receiver, it will not move to the next state, that is it will not get the data from the application layer. So it is waiting in the state called acknowledgement or negative acknowledgement state. Okay, so what happens here? if it receives. So if as soon as the transport layer of the sender sends or creates the packet and sends it to the receiver, it goes here, and what happens at the receiver side, it receives the packet, RDT receive of packet, and UDT of send negative acknowledgement or corrupt of received packet. Then what happens, if the received packet is corrupted, what happens, it will send the negative acknowledgement. The event is RDT receive of received packet and the corrupt of received packet. This is the event. For that, the action taken is UDT underscore send of negative acknowledgement. What will happen if the received packet is corrupted? What is the action taken? The action taken is send the negative acknowledgement. So what happens, at the receiver side, the transport layer will send the message to the sender that sender saying that I have not got the correct data, by sending the signal called negative acknowledgement, message called negative acknowledgement, UDT of send comma negative acknowledgement. If it gets the data correctly, what it will send? So it will send the UDT underscore send of acknowledgement. Okay, so RDT of underscore receive of received packet and it is not corrupted, then what will be the action taken? Extract the received packet from the data and delivers the data to the application layer. And one more thing what it has to do is, it has to send the acknowledgement to the receiver. Clear? Receiver side, if it gets the data without any corruption, then it will give the negative, it will send the acknowledgement to the sender and it gets the data, delivers the data to the application. After extracting the data, it delivers it to the application layer. If the data is corrupted, then it sends the negative acknowledgement. Okay, so what happens at the sender after getting the acknowledgement or the negative acknowledgement? That's what we are going to see now. See here, if the sender is getting RDT receive of received packet and is negative acknowledgement of the received packet, and if it is going to be the negative acknowledgement, what it should do, it has to resend the data. See here, UDT send of send packet, the same packet send SNK PKT is there, right? The same packet will be sent, resent. Okay, after sending the packet, again it will move to the same state called wait for the acknowledgement or the negative acknowledgement, because once it resends the data, it should wait again for the acknowledgement for the data which has been sent for the second time. If it gets positive acknowledgement, it will move to the next state. If it doesn't get the positive acknowledgement, instead it gets a negative acknowledgement, it will once again resend it and it will stay in the same state. Okay, so what happens if it is getting positive acknowledgement from the sender side? See here, RDT of received packet and is acknowledgement received packet. See here, his acknowledgement received packet, no action to be taken. If it gets the positive acknowledgement, no action to be taken, just it will be moving from the acknowledgement or negative acknowledgement state to the wait for the call from the above. It means that it can go for the next data transfer. It can wait for the next data from the application layer. Clear? This is what happens in RDT 2.0. Operation with no errors. This is how data moves. This is error scenario. The same thing is explained once again. Some error scenario. Next. Delivers data, no action. Next. What is the flaw in RDT 2.0? If you see that sender doesn't know what happened at the receiver. It can't just retransmit for possible duplicate. It cannot retransmit so many times. Okay, that is the problem in the RDT 2.0. So how can we handle the duplicates? To keep on, if the data is sent by the sender, how the receiver can handle the duplicates? So for that, they have invented a new concept called sequence number. So the sequence number is introduced in RDT 2.1. See here the sequence number. If I have two data, okay, data 1 is numbered as 0, the sequence number 0, and data 2 is numbered as the sequence number 1. See here, this is the sender side, So what happens? At the sender side, as usual, the transport layer waits for the data from the above. This is for the data 1, first data. So it is called as call 0 from above. The sequence number is 0, so call 0 from above. So as we said, the transport layer will initiate the event called RDT underscore send of data. For that, the action taken by the transport layer is send packet is equal to make packet of 0 comma data comma checksum. In RDT 1.0 we saw only data in the parameter. In RDT 2.0 we saw data comma checksum in the parameters. In RDT 2.1 we are seeing sequence number, that is 0 is the sequence number of the first data comma checksum. Okay, so RDT 2.1 has 3 parameters in the make packet. 0, that is sequence number comma data comma checksum. After creating the packet, it sends the data. Okay, so once it sends the packet, it will move to the next state, that is wait for the acknowledgement or the negative acknowledgement state. So in this state, what happens? It receives the packet RDT of receive packet. This is the message which it gets from the receiver. If the receiver finds that the data received packet is corrupted and it is negative acknowledgement or negative acknowledgement, either it is corrupted or negative acknowledgement, what it has to do, it has to resend the packet once again. If it receives RDT receive of receive packet and not corrupted of receive packet and is acknowledgement of receive packet, what it should do, it should not take any action, it can go for the next data. Okay, the data 1, it has transferred the data 1 successfully, so it goes for the next data transfer, that is data 2's data transfer, whose sequence number is 1. The same process takes place again. It creates the packet, but the sequence number will be 1 here. Then it sends it to the underlying layer. After sending the data, it goes to the next state, that is acknowledgement or the negative acknowledgement 1. What is this 1? Sequence number of the second data. That is 1 is the sequence number of the second data, 0 is the sequence number of the first data. So what happens? The same thing, it goes to the receiver. If the receiver finds that the RDT of received packet and not corrupted and the received packet is acknowledgement, then no action to be taken, it goes to the next state. But if the receiver finds that it is corrupted and it is negative acknowledgement, then the data should be transferred once again. Clear? The data transfer happens once again and it goes to the same state. This is what happens at the RDT 2.1 at the sender side. So what is the disadvantage in it? So sequence number, see, if we have so many data, 4 or 5 data, the sequence numbers cannot be multiply 0 1 2 3 4 5 like that we cannot make, and must check if received acknowledgement or negative acknowledgement corrupted, and that is also required. Twice as many states, so if the number of data increases, states also will increase, which will lead to confusion. Receiver must check if received packet is duplicate. So if at all acknowledge 2 or 3 times the same data is transferred, it should be checked by the receiver whether it is a duplicate or not. So receiver cannot know if it's last acknowledgement or negative acknowledgement received okay at the sender. So this is another problem in RDT 2.1. So in order to resolve this, they have invented the next protocol, that is RDT 3.0, which we'll see in the next